Hello, in this episode, I'm going to discuss, or in this lesson video, I'm going to discuss how to construct a probability distribution for a certain random variable. This is under the topic probability distributions for discrete variables. Suppose we have a problem here. An experiment consists of rolling a pair of dice and letting the random variable x be the number of times the number 1 comes up when a pair of dice come to rest. Let's take note that on the same sample space of an experiment, many random variables can be defined. So it will have different probability distributions. For this example, let's just have the random variable x be the number of times that the number 1 comes up when a pair of dice is being rolled. So we have here sample space for possible outcomes when the two pair or a pair of dice is rolled or when it comes to rest. So here we have, it could have 1 and 1, 1 and 2, and so on. This is equal to 36. 36 sample space or cardinality of space. Again, let's have our x here, representing the number of times 1 occurs in a roll of the dice. Alright, so that we will not manually count the number of times 1 occurs in a row of dice. Let's use Excel formula count if. So count if among these two columns 1 appeared. Okay, and then let's drag down. Let's drag down to copy the formula all the way to the last row. So we have there. So in the pairs or in the values of x where it appeared to be 0, it means, or it's obviously in the outcomes 1 did not occur or did not turn up. Okay, next, shall we have here x? X could be 0, 1, and 2. X can take the values of 0, 1, and 2, meaning number 1 can turn up either it won't turn up in any of the dice, or it can turn up once only, or both of the dice can turn up or can show up number 1. All right, so let's count how many times that x is equal to 0. Let's use again count if function, and then our range here, because we're going to identify, or we're going to determine how many times that 1 didn't turn up. And then let's use the function of f4 so that the value won't change, and then criteria is 0 because x is equal to 0. Okay, and let's drag down the formula. Let's change the criteria here. X is equal to 1, and our x here is equal to 2. Summing it up, this should be equal to 36. So this means that 0 occurs 25 times, or 25 in the sample space, 25 events turned up to be 1 did not show up, or it did not turn up, or it did not occur. And 10 times that, or 10 events in the sample space that 1 occurred, and 1 occurred once only, or one of the dice turned up to have 1, and once only that both of the dice turned up 1. Okay, let's compute for the p of x, or the probability distribution function for x. Now let me emphasize that the probability distribution function for x has the properties that p of x, the values here should be greater than or equal to 0, and the summation of p of x is equal to 1. How do we solve? Using Excel, it is equal to 25 divided by 36. Again, let's use the function of F4 so that the value won't change. And then let's limit to until 3 decimal places. And let's drag down to copy. All right. All the values of p of x are greater than 0. And then summing it up, it should be equal to 1. Okay. Now this is now the probability distribution of x, random variable x. Again, let me emphasize that x is the number of times or equal to the number of times 1 occurs when on a roll of dice. Next in line is how do we construct the cumulative um, probability distribution. Again, cumulative distribution function associated with x. So let's have here our x, 0, 1, 2. And then our cumulative, let's have f of x. This is equal to the first, or x. When x is equal to 0, p of x is equal to 0.694. Because it's cumulative, 0 when x is 0 plus when x is equal to 1. And then when x is 0 or 1 plus when x is equal to 2. It should be equal to 1. If it's not equal to 1, then there's something wrong along the way. So this is how the probability distribution function is constructed together with the cumulative distribution function. Now, had the random variables had a different or maybe be defined differently, of course, the probability distribution would be different as well. Okay, this is using the MS Excel. Another features here, we can construct also the graph, and we can identify whether it is skewed to the right, or it has a tail to the right, or it's skewed to the left, or it has a tail to the left. However, it can be discussed in the succeeding lessons when we are going to discuss the normal probability distribution. Okay, so I hope you are learning something from this lesson video, and you will be ready to answer an activity related to this. All right, thank you and God bless.